All right, guys, welcome to day 2 of 2.2.5. So last time we started on the first 2 of these, and today we're going to finish those off and then do a few more things before wrapping it up. So I'm going to hop back over to this view, and we did the negative f of x and the 1/2 f of x last time, so now we're going to take a look at first f of x plus 4 and see what that does. So I'm going to take my old value of f of x and I'm literally just going to add 4 to it. So that's all we're doing, is just adding 4 a whole bunch right now. So if I add 4 to all these, I would get 2 and 2 and 2, and that's going to be 1, that's going to be 0, be negative 1, 0, 3, and then 8, 8, 8, and 8. Right. So now if I plot all of those, I'm here at 2, 2, 2, 1, 0, negative 1, 0, 3, and then 8, 8, 8, 8. So now if I draw my lines there, that one, and then my parabola going up, and then I'm horizontal there. And again, it's not drawn perfectly, but you get the idea. It's the exact same shape, just everything got shifted up 4, which is what you should expect, right? This is no different than any other function. If I add 4 of it, this takes the entire function, shifts every value up 4. Awesome, great. Now let's take a look at this last one, right? So this is going to be a minus 4 inside of the x. So I've already kind of started this off and said, well, take these x values and minus 4. Spoilers, that's what minus 4 does to the numbers 0 through E11. And now, to figure out what the f of negative 4 is, we kind of want to be able to reference back to this here. Okay, so f of negative 4 is negative 2. So when I say the f of x minus 4 when x is 0, I'm effectively saying the same thing as, hey, what's the f of negative 4? So then this becomes negative 2. And then plugging in a 1 is effectively the same as plugging in a negative 3. Well, over here, a negative 3 gives me a negative 2. And since these really follow the exact same pattern, what I'm going to see is that all of this is going to be exactly the same as I had there. So then I would get negative 2, negative 3, negative 4, negative 5, negative 4, negative 1, 4, 4, 4, 4. Now when I actually go to plot these on my graph, keep in mind this is my x, this is my y. I do not need that middle row at all. Okay, I'm just using the x on top, y is on the bottom. So the first one is the point 0, negative 2. And then 1, negative 2. And then 2, negative 2. And then 3, negative 3. And then 4, negative 4. And then 5, negative 5. And then 6, negative 4. And then 7, negative 1. And then 8, 4. And then 4, 4, and 4. So when I go to drawing all of those in, I get this shape here. There's my parabola. And then horizontal going there. So again, it's the exact same graph as I had originally, but now it got shifted all to the right 4, which again is what we predicted. Okay. The whole point I was going to say, because we've already gone over these rules, it's just trying to reinforce what all of these things do, while at the same time showing us, hey, here's what it looks like on a piecewise function. It's the exact same thing, right? Don't fret about it being piecewise. All of those rules still apply. That's why we try to learn all of those rules. Okay, so here we go for 1, 5, 7. So what I want you guys to do here is graph these on Desmos, and then from the graph, is it even, is it odd, or is it neither? Okay, and then focus on how can you tell. Again, remember those like rules for reflections and things like that. And then once you're done there, 158, write an equation of your own even function, then write your own odd function. Spoilers, we're going to do one that's on either as our closure. All right, so go ahead and pause and do that, then come back here. Okay, so let's go ahead and go through these real quickly. Put my Desmos, there we go. All right, so the first one that we wanted to graph was x to the second. Now, this one is obviously even because we are reflexive over the y-axis, so not too hard there, easy peasy. All right, next one. If we go x plus 5 in parentheses and then raise that to the second power, now I've shifted my graph to the left. This is no longer reflexive over my y-axis, so it's not even. Well, is it odd? Well, if I do a vertical reflection, I'd be down here. Horizontal, I'd be over here, so those are going to be different, so it's not even, it's not odd, it has to be neither on that case there. Then if we do x to the second plus 5 on the outside, well, now this is going to be even again, right? Because it is reflexive over that y-axis. So again, I'm back to being even. If I do x to the third, this one is not even because it's not symmetric over the axis, right? Because this would go over here to where there's nothing. Then, hey, is it odd, right? If I do a horizontal reflection, I look like this. If I do a vertical reflection, I look like this. And hey, that's the exact same thing. So yes, that one is going to be odd. Well, then what if I do this one of x minus 5, or sorry, plus 5 raised to the third. So on this one, if I do it's not symmetric over the y-axis a again. If I do a horizontal reflection, I'm over here. Vertical, I'm back over here. So my vertical and horizontal are not as well. So hey, not going to be even nor odd, so that one is going to be neither. Then what if I put that plus 5 on the outside of it? Because that helped on the last one. Well, here, I'm not symmetric over the y-axis, so I'm not even. A vertical reflection would cause me to be down and have this crossing point be down here at -5, whereas a horizontal would look the same and have that crossing point still there at 5. So once again, horizontal and vertical reflections are different. This one too is neither even nor is it odd. All right, then we got 1 over x. On this one, we're not symmetric over that y-axis, so we're not even. Then if I do a vertical reflection, this part would go down here, and I'd be this kind of bottom right corner. This part would be up here, and I get the top left corner. If I did a horizontal reflection, this goes over to the top left, this goes over to the bottom right, so I get the exact same thing out of my vertical and my horizontal reflections. Awesome. And then the last one we're looking at, so that means that it is odd. I forgot the most important part there. In our last one, we're doing -2.5 x. So if I do a horizontal reflection, it's not symmetric, so that one's not going to be even. And then if I do a vertical reflection here, this would go down here, this part would go up here, and if I do a horizontal, this goes over here, and this goes over here. They're going to be the exact same thing. So this one is odd, even though it seems kind of weird, and it ends up being odd on that one as well. So that's the big thing I want us to feel comfortable doing. So on whatever you drew, just double check your evens should be symmetric over that y-axis, meaning if you fold it on that y-axis, you would get a mirrored shape, and it is the same. Your odd one should have the vertical and horizontal reflections give you the same output for both of those, so just double check that. Okay, oops. So, our closure. How about a function that has neither even nor odd? So go ahead and pause, try and figure out how you could do that, check it on Desmos. Okay, so with this, I do want to talk about what you've likely been noticing. Okay, and that kind of deals with what's even, what's odd and what causes those things to happen. So I'm going to pull up my document camera and I'm going to show us some examples. Okay, so things that were even, x squared was even. Right? Things that were odd, x to the third, those are both odd. X to the fourth is also even. Guess what else is even? X to the sixth, x to the eighth. Odd functions, x to the fifth, x to the seventh. If you graph all of these, you're going to get even things. If you graph all of these, you're going to get odd things. So you can likely say, hey, well, that's why we call them even and why we call them odd. Easy, right? But what if I did stuff like x squared plus 2x minus 1? Well, that's even, that's odd as far as powers go. This one I'm not really quite sure, right? Because it doesn't really have an x2 power, right? So if we graph this, we end up getting neither. Well, that makes sense because we have a kind of a mixture there. Well, what if I did x squared plus 5? 5 is an odd number, but that ended up being even for us, right? Because the number itself doesn't really matter here. What matters is that this is like having x to the 0 power. Now 0 is even, right? For all intents and purposes, it's even. It's its own kind of special thing, but it is still defined as being even. So this is really, hey, that's even, and that's even, so I get an even function, right? If I did x to the third plus x, well, that's odd, and that's odd. Guess what? This gives you an odd function, right? But what if I did x to the third plus x squared, right? Well, that's odd. That's even. I have a mixture. It's going to be neither. Okay. Now you're probably saying, well, why didn't we just talk about this at first? Because who really cares? That's because this works for those basic polynomials, but there's other things that are even and odd which don't follow this exact rule. But this is where that naming comes from. Like we saw, 1 over x was an odd function, and then that really doesn't follow these same rules. It kind of does because this is like x to the -1 power, -1 is still odd. But what if I did stuff like the absolute value of x? That's even, right? So that really isn't an even power at all, right? But it isn't still an even function. So we use those names because for a lot of these base polynomials, we can use that shortcut to determine, hey, is it even or is it odd? But there are things that are not going to follow that, which still can be classified as even or odd, and you're going to encounter more of those as you move forward in math. So I did want to kind of point that out because likely you're kind of starting to see those patterns, which is awesome. I just wanted to address it so that you don't have any kind of misconceptions going forward. Okay, so with that, here is our that's labeled wrong. It's not the closure, and it is the assignment. Oh, sorry, this is the closure for chapter 2 because I gave you all the homework. Sorry. This is our chapter 2 closure, so this is effectively going to act as your homework for chapter 2, 170 through 182. You can get started on this today if you would like, but tomorrow is the day which we're actually going to have scheduled to work on this. So with that, I will talk to you next time.